This video is going to focus on drawing a box plot, but one of the key skills involved in drawing a box plot is the ability to identify an outlier. So we'll come back to the outlier part. First, what we need to know is the key components that make up a box plot. So to begin with, we need to know the minimum, we need to know Q1 or the lower quartile, we need to know the median, which is also called Q2, Q3 stands for the upper quartile, and we need the maximum. So the minimum is the lowest score, the median is our middle score when we arrange the data in order from lowest to highest, and the maximum is the highest score. From there you can find your lower quartile value by finding the middle score from the lower half of the data. You can find your upper quartile score by finding the middle score from the upper half of the data. The other components of a box plot include the left whisker and the right whisker, and the middle section is our box plot. Something else that's good to be aware of is the fact that 25% of the data will lie in each quarter of the box plot. So the left whisker here has 25% of the data in that section. The left section of the middle box has 25% of the data, the right section of the box has 25% of the data, and the right whisker has the other 25% of the data. Sometimes you'll be asked to describe the shape of a box plot or the shape of the data distribution. Here we've got a symmetric box plot, a positively skewed box plot, and a negatively skewed box plot. And you can have a look at the difference between those if you want to. We're going to focus more on drawing a box plot. So here in example 1, we've got a set of data from 8 to 18. Step 1, arrange the data in order. So we've done that already. Step 2, find the 5 key values. So you need your minimum, your Q1, Q2, Q3, and maximum. The minimum and the maximum are quite easy, the lowest and the highest scores. So the minimum is quite clearly 8 and the maximum is 18. So I've got those in below. To find the median or the Q2 value, you need to find the middle number. And sometimes there's two middle numbers. And in this example, there are two middle numbers, 13 and 14. So what you do is you add the two numbers up, 13 plus 14. Now I'm not too strong with my addition. So 13 plus 14 is 27. And then 27 over 2 is 13.5. So our median is 13.5. The next one we're going to do is Q1, so that's the middle of the lower half of the data. We need to split our data into two halves, and when we do that, because there were two middle values as the median, 13 goes into the lower half of the data and 14 goes into the upper half of the data. So we'll focus on the color-coded red section for now, and the middle number in this red section is 12 and 12. So our Q1, there's no point adding them up and halving them, but we can just to show you 12 plus 12 is 24. And then when we divide by 2, the middle number is still 12. So our Q2 value is 12. And when we find the middle two numbers of the yellow section, it's 16 and 17. So 16 plus 17. And then we divide by 2 and it's 16.5. So that's our last of our 5 values that we need to draw a box plot. Now, we're kind of ready to draw the box plot, but we haven't checked for outliers yet. So what we might do, we might stop there and focus on outliers for a second. What an outlier is a number that's greater than or smaller than numbers that you get when you apply this formula here. And we'll demonstrate that in a moment. What they are is an extremely large number that's separate from the rest of the data, or an extremely low data that's separate from the rest of the data. And because the numbers are either very high or very low, we don't draw them on our box plot. We actually draw them as a separate dot away from the box plot to show that they're an outlier. So our first test is we'll do the greater than. So if a number is greater than the number that we get from this formula, we consider it to be an outlier. So Q3 plus 1.5 times IQR. IQR stands for interquartile range. Our interquartile range is Q3 minus Q1. Q3 is 16.5 and Q1 is 12. So our interquartile range is 4.5. So if we're going to work this out, our Q3 value was 16.5. We're going to multiply that by 1.5, plus 1.5 times the interquartile range, which is 4.5. The answer to that is 23.25. What that means is anything above 23.25 is an outlier for this data above. Our biggest number is only 18, so there are no high outliers. Now we can check for a low outlier. We'll do that over here. Our low formula is Q1 minus 1.5 times interquartile range. Our Q1 value was 12. So 12 minus 1.5 times the interquartile range, which is 4.5, 5.25. So for an outlier to be considered, it would need to be below 5.25. Our lowest number is 8. That was our minimum. So there's no low outliers. So we can draw this box plot without worrying about any outliers. The way we draw it is we set up our scale. So we notice that it starts at 7, finishes in 19. So we've got enough room on this scale to cover our minimum, which was 8, and our maximum, which was 18. So we can fit that in our scale. That's really important. Make sure you draw your scale with even intervals of numbers. Mine are going up by 1 in this example. That yours don't have to go up by 1, but they need to go up by a consistent interval. Now we draw our 5 key values in. Our minimum goes in as a dot, and our maximum goes in as a dot, and the other 3 values, Q1, Q2, and Q3, go in as vertical lines, and then you can join everything up using horizontal lines. So here's our left whisker, our right whisker, and then our box plot. And there we have it. We've got our Year 9 English results with scores out of 20 represented as a box plot. And there's no outliers in that example. 3:20. I should go home now. Alright, we're going to look at an example that does have an outlier. So in this example, the times in seconds achieved by the 12 fastest runners in a 100-meter sprint at school are listed below. So the quickest time was 11.0 and the slowest time was 12.7. So there's our minimum, our maximum. We've worked out Q1, Q2, and Q3. So we've got everything we need for a box plot, and they've even worked out the interquartile range to help us work out the outliers. Here's our low range outlier. Alright, there's the working out there. So if anything is below 10.375, then it is an outlier. Now our lowest value was 11.0, so there's no low outlier because there's nothing lower than 10.375. If we look at the other working out for a high outlier, it's anything above 12.575. Have we got anything above 12.575? This score here. So 12.7 is a high outlier. So what we do is we draw 12.7 here as a separate dot. And normally what we'd do, if you look in this diagram here, you might draw it like an open dot, not necessarily coloured in. So keep that dot sort of as a circle rather than filled in if you like. So we've drawn all the other points. We've got 11.0 as our minimum. Now our maximum is 12.3, you'll notice, because that's our next biggest score. That's our new maximum that's not an outlier. So that's really important. Here's our new max that's not an outlier. And then this dot here is separate because it's an outlier. We've got our other values, our Q1, 11.2, our Q2, 11.35, and Q3, 11.75, and joined it all up as a box plot. You'll notice that this axis is different. It goes 11, 11.2, 11.4, 11.6, 11.8, then 12.0, 12.2, 12.4, 12.6, 12.8, 13.0. So there's a different example of how that axis is set out, but it still has consistent intervals in the difference between each line. So here's a quick summary of the steps involved to draw a box plot and check for outliers. First, arrange your data from lowest to highest. Then find your 5 key values, your minimum, your Q1, Q2, Q3, and your maximum. Step 3, check for outliers. If there is an outlier, you might need to adjust your minimum or your maximum value if there is an outlier present. Then draw your scale, draw your 5 key points in, and then join the box plot together.